Welcome to Easy Elimu Learning Simplified. My name is Eric. I'll be taking you through this topic, greatest common divisor. And for this lesson, we'll be looking at finding GCD by successive division. So these are a continuation of our previous discussion on GCD by successive division. Only that now for this lesson, we're going to look at the GCD of numbers that are relatively larger. So we have GCD by successive division, and then at the end of the lesson, we'll be able to give you some assignment to help you practice on the concepts as discussed through this lesson. So we have our first example here. You can see now, if you look at the examples we dealt with in the previous slide, the examples were relatively smaller, or the values that we used previously were relatively smaller. Now we're going to deal with values that are relatively larger. So this is successive division method. So we have the GCD of 1000. So you have 1000. And then we have 1500. And then we have 3000. So I want to find the number that can, the greatest number that can divide the three numbers, exact number of times without leaving any remainder. So we start by, we just use the prime numbers. So I'll start with 2. 2 divides 1500 times. 2 divides 15, 7, remainder 1, 10, 5. Remember, 15 divided by 2 is 7 because of 14. Remainder is 1. Take it to 0. That becomes 10. 10 divided by 2 is 5. Then you add the 0 there. Again, 3 here divided by 2 is 1. Remainder 1. Take it to the next one, becomes 10. 10 divided by 2 is 5. Then you add the 2 zeros. So again, you have 2 because they are all ending in a 0. So 500 divided by 2 is 250. So we have 5 divided by 2 is 2. To give us 4, remainder is 1. 1 take you to the next digit, which is 10. 10 divided by 2 is 5. Then you add the 0. Again here, 7 divided by 2 is 3. That is 6. Remainder 1. 1 take you to the next digit, becomes 15. So 15 divided by 2 is 7. Again, because of 14, remainder is 1. Take you to the next digit, that is 10. So that is what you have. The same applies to this. 15 you divide by 2 is 7. Remainder 1 because of 14. 1 taken to the next digit is 10. 10 divided by 2 is 5. So here we cannot use 2 because remember, for GCD, as we discussed in the previous slide, the number, the prime number picked here must be a factor of all the numbers. You see there are 3 numbers here. We have 250, 375, and 750. So that is the number we select here. So for example, if we picked 2, that 2 is supposed to be a factor of all. So see, the middle one, 375 here is not divisible by 2 because it doesn't end in a 0 or an even number. So maybe I'll try 3. Not possible because if you add the digits here, you get 7. 7 is not a multiple of 3. So let me go to 5. So 25 divided by 5 is 5. Then I add the 0. 37 divided by 5 is 7 because of 35. The remainder is 2. 25 divided by 5 is 5. 7 divided by 5 is 1. Remainder 2. 25 divided by 5 is 5. Then 0. Again 5. So 50 here divided by 5 is 10. 75. So 7 divided by 5 is 1. Remainder 2. 25 divided by 5 is 5. 15 divided by 5 is 3. Then again 5. 10 divided by 5 is 2. 15 divided by 5 is 3. 30 divided by 5 is 6. So you see now all these numbers, we don't have a common factor that can divide them other than 1. So you stop. So when you reach that level, you simply multiply these ones. So you'll write that the GCD of 1,000, 1,500, and 3,000 is equals to 2 by 2 by 5 by 5 by 5. So that is going to be 5 by 25. I mean, 4 here. 2 by 2 is 4. 5 by 5 is 25, and then by 5. So you try to multiply any 2 that will give you a number that is ending in a 0. That is easier. So 25 by 4 is 100. And 100 by 5 is 500. So it means the GCD of the greatest number that can divide all these, all the 3 without leaving any remainder is 500. So that is how you do it. So these numbers are relatively larger compared to the numbers that we dealt with in the previous slide when we were talking about successive division. So we have the second example here. We're supposed to use successive division method to find the GCD of the following numbers. So the approach is still the same. We just have 1,200 here, 2,400, and 4,800. Then you try find a prime number that can divide all of them, and that is 2, because you can see they are all divisible by 2. They are all ending in a 0. So 12 here divided by 2 is 6, and then you add the 2 zeros. So here we have 2 divided by 2 is 1, 4 divided by 2 is 2, and then you add the 2 zeros. 4 divided by 2 is 2, 8 divided by 2 is 4, then you add the 2 zeros. All these are still divisible by 2. So 6 divided by 2 is 3, you add the 2 zeros. 12 divided by 2 is 6, you add the 2 zeros. 2 divided by 2 is 1, 4 divided by 2 is 2, then you add the 2 zeros. So again, they are all divisible by 2. So 3 divided by 2 is 1, cos of 2 remainder 1. 1 taken to the next digit is 10. 10 divided by 2 is 5, then you add 0. 6 divided by 2 is 3, and 12 divided by 2 is 6, then you add the 2 zeros. Again, still 2 is applicable, so for 15 here divided by 2 is 7, cos of 14 remainder is 1. 1 taken to the next digit is 10. 10 divided by 2 is 5. 3 here divided by 2 is 1, remainder 2, so there is remainder 1. 1 taken to the next digit is 10. 10 divided by 2 is 5. You add the last 0. 6 divided by 2 is 3. Then you add the 2 zeros. So we can still, so 2 is not possible. So you can't divide by 2 here, because the number picked here must be a factor of all of them. So 75 here is not divisible by 2. So let's try 3. So 75 is divisible by 3 because when you add 7 to 5, that is 12, and 12 is a multiple of 3. So that is 25, that is 30, and that is 100. So next is 3, not possible because 25 here you add the digit 7. So 7 is not divisible by 3. So let's try 5. So 25 divided by 5 is 5, 30 divided by 5 is 6, and 10 divided by 5 is 2, then you add the 0. So you can't find a number that can divide all this. So you just need to multiply all these numbers on the side here. So we now have GCD of 1,200, 2,400, and 4,800 to be equal to 2 by 2 by 2. So there are 4 2's by 2 by 3 by 5. So 2 by 2 is 4, 4 by 2 is 8, 8 by 2 is 16. So this is 16 by 3. by 5. So I'll try multiply 5 by 16 because this will give me a number that is ending in a 0. So 5 by 16 here is 80. Then you multiply by 3. So 3 by 8 is 24. Then you add the 0 here. So it means the LCM, I mean the GCD of 1,200, 2,400, and 4,800 is 240. That is the number that can divide all these three. We say the largest number. There are very many numbers that can divide them. Can divide all of them. But here we're talking about the largest number that can divide all of them without leaving any remainder. So there's 240. So let's look at our last example on this. So again, we are supposed to use successive division method to find the GCD of the following groups of numbers. So we have 600, 800, and 1,200. So again, we have 600, 800, then we have 1,200. So 2 is common because they are all ending in a 0. So this is 300, this is 400, and this is 600. Again, they are all ending. So divisibility test is important here. So again, 2. So 150. Then we have 200. Then we have 300. Again, 2 because they're still all ending in a 0. So we have 7 because of 14 remainder is 1. Take 1 to the next 0 becomes 5. Becomes 10 divided by 2 is 5. So 2 divided by 2 is 1. Then you add the 2 zeros. 3 divided by 2 is 1. Remainder 1. Then 1 taken to the next digit is 10. 10 divided by 2 is 5. So now they are not all divisible by 2. So 3 again, no, because 100 here, if you add the digits, summing up the digits, 100 here is 1, and 1 is not divisible by 3. So 3 no. So try 5. So 75 divided by 5 is 1, 5. 7 divided by 5 is 1, remainder 2. 25, 2 taken to the next digit is 25 divided by 5 is 5. 10 here divided by 5 is 2, so that is 20. And 15 here divided by 5 is 3. That is 30. Again, 5 is applicable. So 15 divided by 5 is 3. 20 divided by 5 is 4. And 30 divided by 5 is 6. So we have now the GCD, or the greatest common divisor of, this is how you're supposed to frame your answer, of 600, 800, and 1,200 equals to, so you multiply all these. So 2 by 2 by 2. 2 is multiplied 3 times. And then 5 by 5. So here it is easier to multiply 2 and 5, then you multiply this again and that, so that you end up with numbers that are ending in a 0. For example, 2 by 5 is 10. Again, 2 by 5 is 10. And then you multiply by 2. So you see, this is just 100 multiplied by 2, which is equals to 200. This is an easier way of working out these problems without a calculator. So 2 by 5 and again 2 by 5. Then what remains now is this 2 here. So 2 by 5 is 10. Again, 2 by 5 is 10. Then what remains is 2. So 10 by 10 by 2, which is 100 by 2, which is 200. This is a simpler way of doing the same problem. So we have a few questions to help you practice on what you've been learning. These are relatively larger numbers. So these problems here can help you practice and also to just help you gauge on your understanding of the concepts as we have discussed through this lesson. So that marks the end of this lesson. Goodbye.